7, problem 5 reads, a baseball is thrown from the roof of a 22-meter tall building with an initial velocity of a magnitude of 12 meters per second and directed at an angle of 53.1 degrees above the horizontal. So A, what is the speed of the ball just before it strikes the ground? And you need to use energy methods and ignore air resistance. B, what if the angle is 53.1 degrees below the horizontal? What is the velocity of the ball? And part C, if there was air resistance, which one would have, what does it say? If the effects of air resistance are included, will part A or B give the higher speed? So, really simple. Here's a little drawing. So you got your building, 22 meters, 53 degrees below and above. So just our variables we have. Mass doesn't matter because it's going to be in every term and everything will cancel. So you can do this with with a planet if you really wanted to. The mass doesn't matter. Of course, that'll throw off gravity. But the point is, so your initial energy is going to be the gravitational potential, which is mgh, plus half mv1 squared, v1 being its initial velocity. V2 is going to be the final velocity, and the final energy, since gravitational potential energy is 0, is just going to be half mv2 squared. So you can knock out all the m's, make things a little bit easier on yourself, multiply everything by 2, so that the square root of v1 squared plus 2gh will equal v2. Throw that into a calculator, and the ball will be traveling at approximately 23.99 meters per second when it hits the ground. Part B, what if the angle's below? Well, it doesn't matter for the sake of this problem, because at some point all it's going to do if it goes up is just lose kinetic energy, hit a peak in gravitational energy, then come back down. We don't care about all this up here. It's just getting to this point faster. But we don't care about time. And there's no air resistance, so that doesn't really matter. So the velocities are going to be the exact same. Part C, which one's going to be going faster if there is air resistance? Well, the first, pretty much, they're going to... I'm trying to think of an easy way to explain this, but pretty much part B, going down, is going to be faster. Because if you throw up, you have air resistance blocking you all the way on your way up and on the way down. Well, this one just has the way down. There's much less time for air resistance to happen. And you're going to have pretty much when the ball is on its way down from the top one, it's going to look almost the exact same as your initial part heading if you were heading straight down. You just have all this extra time that air resistance can work on it. So that's why part B is going to be going faster if there is air resistance.